Hello, I'm Stefan Kleber. I'm the project leader for LXD, and in this video I'd like to go deeper into clustering things. So for the past two videos, we've been going over integration between LXD and other technologies to improve the clustering experience. The first one was on software-defined network and using OVN to get a distributed software-defined network and have LXD integrated with that to place instances on those virtual networks. The most recent video was on creating a Ceph cluster, so software-defined storage, to similarly run instances on a distributed storage layer that also brings in high availability for LXD instances. In both cases, I showed how to assemble a quick LXD cluster and connect it with the relevant technology. But what was asked a few times was, okay, can you do a video now showing what you actually get to do with a cluster that's deployed using those technologies? So that's what I'm going to be doing today. I've got 8 systems here that I've allocated from the LXD team's lab. So there are 8 virtual machines, 6 Intel-based ones, 2 ARM64-based ones. So as we can see, like those bottom 2 are on ARM instead of on Intel. And they all have 4 virtual CPUs, 4 gigs of RAM, 3 disks. One that's used for the boot drive and will be used as local storage for some instances, and then 2 external drives that are 100 gig each that are going to be used for Ceph. And I'm using MAS in this case because, well, we already have it. It's a very easy way to get very consistent systems that I can easily reprovision if needed, or throw away the minute I'm done with this video, pretty much. It's also significantly cheaper for us than using the cloud because those systems are effectively free, the machines already exist. But if you want to follow along, you can totally do that in the cloud or using physical systems you might have laying around. Also worth noting that I'm doing this demo using 8 systems. That's not strictly needed. You can do all of this with as few as 3 systems. And let's get into it. So all of those systems are running Ubuntu 20.04. I'm also running the HWE kernel, so that's more recent than the stock kernel. The reason for that being that those are virtual machines and I want to show running virtual machines, and for VM nesting I needed a slightly newer kernel. So that's the only weird part of that setup, I suppose. So switching to a terminal, I've got all 8 systems here, so connected to all of them. Most of the time I'll just focus on one at a time, kind of zoomed in. We'll only really show all 8 at the same time when doing a repetitive action, like joining them into the cluster, which is unfortunately going to take a little while as I'm going to have to do it 7 times. But yeah, the rest is going to be done just either from one of the systems or from my desktop computer. So let's start by looking at the first system here. So this is the first Intel server of the bunch. And I've already created a Ceph and OVN cluster and put that in place because we already have videos on how to do that, so I didn't want to just repeat myself. Plus it's a reasonably lengthy process that I didn't want to put in this video. So if we look, there's a Ceph cluster running. It's got 3 monitors, one on Intel 01, 02, and 03. It's got the exact same set of servers for the Ceph managers, the Ceph MDS, and then each server is providing 2 OSDs. Just as a reminder on the Ceph terminology, Ceph monitors effectively keep track of placement groups, so block of data effectively, and where those placement groups are replicated. And clients will effectively reach the monitors and ask for a map for a specific pool, asking, okay, for this pool, who do I need to talk to access the actual data? So the monitor provides that. The Ceph managers are mostly used for background tasks and for monitoring. Then the Ceph MDS is the metadata server, and that's used if you need to run a Ceph file system on top of Ceph block storage. And we do in this case, so I've got some of those running as well. Ceph OSDs are the daemons that run on every single disk and just exposes that disk or partition to Ceph for data storage. And that's pretty much it for the base Ceph setup. If we go into a bit more details, you can see that each server has in fact 2 OSDs running. The storage class is set to HDD. Currently, as far as pools on there, we've got the built-in device health metrics that comes with Ceph, and then the 2 pools needed to back CephFS. Looking at CephFS, we can see the pool is defined and uses those those OSD pools effectively to store the data, so that's all good. And so if we look at the usage, you can see that there's a total of 1.6 terabyte of storage that can be used, and currently it's all empty. Now, the other thing that's set up is Oven, which uses the exact same set of 3 servers. Just one word there, for a production environment, I would not recommend running all of the Ceph control plane and all of the Oven control plane on the exact same 3 servers when you're running 8 identical servers. It's a far better idea to spread that so that they all do some part of control plane management. But for this demo, it was far easier to put that on just the initial 3 because it's a lot easier to reason about and think about like what's running where. So on the Oven side, I've done the configurations through the Oven Central config thing. So we can see that there are 3 servers for Oven, or 3 databases running, and it's set up that way. Open vSwitch was configured on each of the system to access that Oven, and that caused tunnels to be set up. So we've got 8 systems, there are 7 tunnels, 1 to reach each of the other servers. Now, if we look at one of the machines, say that last one, which is the ARM64, the second ARM64 system, that one does not run any of the Oven or Ceph services. The only thing that's running are the 2 OSDs for its disks. And if you look, it's also running the Open vSwitch switch itself, but doesn't run any of the Oven databases. And similarly, if we look at its network config, you can see it's got tunnels to all 7 others set up in Open vSwitch there, and it's got the credentials and everything to access Ceph. So it's all set up for LXD to run on this system. Now, as for LXD, I've got LXD 420 that's installed on each of them, so I don't need to do anything there. If you're just using stock 2004, you're gonna get LXD 4.0, which does not support Oven, so you're gonna want to refresh that to latest so that you get 420, or possibly 421 or later at the time you're watching this video. Okay, so now first thing first, we're gonna be running LXD init on this initial server and get that one going, and then join the other ones later. So the address is correct, we're not joining an existing cluster, the name is correct, no need for password authentication. Gonna be doing local storage on ZFS, creating a new pool, just as a loop, 9 gig is fine. Now this one is asking whether we want remote storage, and we do. So remote storage on Ceph, creating a new Ceph pool. The cluster name is Ceph, that's the default. Then the name for the OSD storage pool, it suggests LXD, which is perfectly fine, it's just LXD. Placement groups, this does not matter as much as it used to, because Ceph, like the Ceph manager, can now dynamically resize pools as needed. So you can just keep the default, and if we need more or less, it's just gonna take care of that for us anyway. Then we're not gonna want to bridge it. Also don't want a fan overlay network because we're gonna be setting up Oven, so none of that. And that's it for the initial config. Now, at this stage, I could go and add the other servers, but I think it's going to be easier to make sure we've got all of the storage in place, all of the network in place on the first one, and then join the other servers. So I'm going to go and do that. The first thing to do, so if we look at the storage list, you can see our local storage pool, which is ZFS. It's used, so that means that the default profile was configured to consume it rather than remote storage, which is fine. We can always override that as needed. And then we've got the remote storage pool for Ceph. We can edit the remote storage pool, and one thing that's useful, I should actually have changed my editor. Not a big fan of Nano, unfortunately. Okay. And so one thing that's worth editing if you're using Ceph is to figure out what's the minimum kernel version you're going to be using on any of your cluster servers. And once you know that, look at what features are supported by the kernel RBD plugin, RBD module, because you're gonna want to set a config key called ceph.rbd.features to the list of RBD features that your kernel supports. So in my case, it's that long list. By default, LXD just does layering, which is the minimum we need to do copy on write for images to instance and instance snapshots. The other options there make it both safer to operate your Ceph cluster, but also makes it significantly faster to check and to snapshot. But if you're running on an older kernel, some of those options might not be supported, and that will result in instances refusing to mount entirely. So just something to keep in mind. Now I'm just going to be saving that. And we're good. Now I'm going to be adding another storage pool. So let's call it remote-fs, and that's going to be cephfs, and the source is going to be cephfs because that's its name. And effectively, the reason why we've got both ceph and cephfs, we're dealing with a cluster, and we're going to have instances across the cluster, so across multiple servers. If we want shared storage between those instances, we need a network file system. We can't, even though Ceph will be shared amongst all of them, we can't share a block volume between them because that would result in file system corruption typically. So that's why, well, LXD won't actually let you do it for that reason, but yeah. So we're creating a additional storage pool using cephfs, which can then be mounted concurrently by multiple instances on multiple servers. And that's very useful if you need to store like a shared website or some other working directory for multiple instances. With that done, we now have all three storage pools, so our local ZFS and remote Ceph and cephfs. Now that's the storage part taken care of. Now we need to do the network part. So the first thing is to configure LXD to access OVN. So that's the network.oven.northbound connection config key, and need to set that to the list of IPs for the three control plane systems effectively for OVN. So I'm setting that, and now we need to create the uplink network for OVN. So right now we've got no managed networks whatsoever, so we're going to be creating a new one called uplink. The name is up to you. I like calling it uplink, it's just easier. Then the parent is going to be BR0. So each of those VMs I'm running have a bridge already called BR0, which bridges their physical network card. You could also use a VLAN or something like that, but in this case, that's how our lab is set up. So I'm just going to be using that as the parent NIC. And there are a few more things that needs to be passed. So let's start with the easy one. So that's the DNS that we want to use for all of the instances. And then we need the IPv4 gateway. So in this case, it's that, as well as the mask. And then same thing for IPv6. If you have IPv6 connectivity, I do in this case. So IPv6 gateway and subnet. And then need to set aside some IPs that can be consumed for OVN's use. So that's IP for OVN ranges. And in this case, the subnet is 32, so let's do 200 to 32.254. And then same thing for IPv6. So in this case, it's going to be something like that. Let's also do 200 to 254. That just makes it easier if it's all lined up. And I think that's all we need. Invalid option for network. Oh, right. I forgot the type. So the type is physical in this case. That should make it better. There we go. Network uplink created. Cool. So with that in place, we should be able to create an OVN network. So I'm going to create a new network called default of type OVN. And now the result is that we have a new network type OVN that's up and running. Good. Let's finally add that to the default profile. So default profile, new interface called ETH0. It's a network interface, and the network is called default, and the name we want the device inside the interface inside of the instance is ETH0. Alrighty. Just to validate this is all good, let's just spin up one tiny instance. I'm just going to use Alpine for that because it's the smallest image, faster to download. There we go. And it's up and running, and just get a shell in there and make sure we've got connectivity to the outside world. All good. So that's another network, got a single instance placed on it, got outside connectivity. Great. Now our cluster only has a single system right now. Needs to fix that before we can do much more with it. So that's going to be the slightly repetitive part of things, where I'm going to need to do tokens for each and every single one of those. So let me run LXD, the beginning of LXD init on all of them, because that often takes a little while, so I might as well get that going. And last one, there we go. So I'm going to generate a token for cluster join, there we go. And then answer, I'll do that one full screen. So are you joining an existing cluster? Yes. Copy the token. Be fine with losing data because there's nothing there. Then it's asking a bunch of questions for things that could differ from system to system. The local storage pool, we're just using the default, so there's no need to set anything. Then it's asking for the source property of the remote file system pool, so that needs to be set to CephFS on each of them. And for the parent network, which is BR0. And that's it. And now to do this another 6 times. So let's get going. This one, and then remote fast, and local is empty, and BR0. Go, and next one. Yes, joining token, yes. Empty, 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 CephFS, BR0. You need to keep in mind that the order of the questions can differ, as you might have seen here. That just happens based on the order in which we're scanning the config we're receiving, and that's not sorted in Go. Okay, joining existing cluster, yes. Token, yes. That keeps you on your toes a tiny bit, because you can't just blindly type them all. Remote fast, it's good, and BR0. Okay. The last Intel server now. Oops, I actually messed that up. So let's start again. Joining, yes. Token, yes. Okay, CephFS, BR0. Good. And now onto the ARM-based servers. Source is CephFS and BR0. Go. And finally, okay, existing cluster, yes. Token, yes. And nothing, CephFS, BR0. Okay. So just waiting for that last one to complete. Takes a few seconds. There we go. Okay, so just going back to the first Intel server and hiding the rest for now. And if we go and list the cluster, here we go. So we've got the first 3 became voting database servers, so they will process the bulk of the database traffic. We've got 2 standbys that are there in case one of the first 3 goes down, so that one of them can be promoted very quickly. And the remaining 3 don't have any roles right now and just act as database clients effectively. Okay, so now that we've got that going, let's launch a few more instances. So I'm going to be doing launch and do C2. That's effectively transferring the image from the first server onto the second one and then creating a container from there. And again, the default profile we have right now uses the local storage. So that's why it's actually unpacking the image every time, because for each of those servers, it's the first time that they're creating an Alpine instance, and so they need to create that in their local ZFS pool. If we're using shared storage, then that would not happen. It would only show the unpack for the initial one. And what's going to be interesting here is to see what happens with numbers 7 and 8, because right now I'm just running on Intel servers, and we've got 6 of those. And LXD effectively just distributes those instances amongst the cluster by picking whatever machine has the fewest instance. So it's pretty much going in the same order as they were drawn right now. So 7 will actually end up landing on an ARM server, and so will 8. So just finishing launching, and then I can show you that. All right, so looking at them, you can see the location here. Oops, there. And indeed, those first 6 are all on AMD, so Intel-based servers, and the remaining 2 are running on ARM. Now, just to make sure that Oven is behaving, oops, there's no bash in Alpine, keep forgetting. Let's see if the C8, which is on the second ARM server, can ping C1, which is on the first Intel server. Yep, no problem whatsoever. And it also has outside connectivity. So that's Oven working perfectly fine. At this point, there's no Ceph involvement there, so the storage is still all local to each of those systems. But let's play a bit more with that. Okay, so there's actually one config key that will be useful in such an environment. As I said, the cluster is mixed, so we've got both Intel and ARM. That behavior I just showed, where I kept asking for Alpine Edge, Alpine Edge, Alpine Edge, and I randomly got 2 of them beyond ARM, is often not very desirable, because users might get a bit confused as to why some random instances are on different architecture. We've got a config key that can be set to avoid, to change that behavior, which is images.default_architecture. And we can set that to x86-64. And that will mean that unless users specifies, everything will be on Intel. So if I was, I'm not going to spend the time right now to do it, but if I was going to do another launch of 8 instances, we would actually say the first 6 Intel servers get an instance, and then it would go back to the first 2 and they would get a second instance. And now if you wanted a Alpine instance on ARM on purpose, you would need to do /ARM64, I believe is what we call that image. And that will specifically now have LXD find a machine of that architecture. So if we do list, we can see that C9 was scheduled on the first ARM64 system. And now if I was to do C10, it would get the second ARM64. But not specifying an architecture, it's going to get you Intel in this setup. So that's a pretty useful trick on mixed architecture clusters, because often you've got less capacity of more unusual architectures than you do more of the mainline architectures. And that lets you kind of save that capacity by not having random stuff get deployed there, effectively requiring it to be specified. Another thing that's useful to do is to just set some descriptions on some of the servers. So in this case, 1, 2, and 3 Intel are also running the control plane for Oven and Ceph. So we could mention that in the description and do Ceph/Oven control. And just put that description field in place on all 3 of them. And that's an easy way to just add some extra data in there. Now we can see exactly what it is. If you're dealing with like multiple power feeds or different labs or different regions, you can also use the failure domain field for that. So one thing, like if you're running in the cloud, that could be like a cloud region or cloud availability zone, for example. So I could do AZ1 here. Let's do AZ1 on that one too. And then put AZ2 on this one, AZ2 on that one. And let's keep going to AZ3 on this one. Okay, so now that's it's gonna be showing different failure domains for those first 6 servers. Yeah, eventually another thing that should start happening is the failure domain is used to better place the database roles, so that effectively it's telling LXD that, hey, those are in the same AZ, and that entire AZ could go down at once. Try not to have all of your databases on the same one, because otherwise it's gonna just completely break. So it's gonna try and reshuffle things and spread them across multiple failure domains. Okay, so that's for the cluster descriptions. It's always quite useful to do. Pretty much all objects in LXD have a description field. Like you could do the same thing for the storage, and put more descriptive definition of what they are. That can be really useful for users. Now, next stage is I'd like to actually connect from an external system. So I just need to get the IP address of this guy, which is here. And if I want to add it from my desktop computer here, normally you would do remote add and call it cluster and just the IP address. But it's going to ask for a password. And so there are 2 ways of doing authentication there. One of them would be I could go and set a password on the cluster, at which point anyone who knows that password can add themselves as a client of that cluster. Or if you want the safer approach, it's to get the client certificate, which can be obtained from the config directory. There's a client.crt file. So you get this guy, and you go back to your server and do client.crt, dump the certificate there. And then you can do config trust add client.cert. And now the client is trusted. So if I go back here, I do remote add, and I just succeed. And then I can switch my client over to talking to that cluster. And if I do list, I get to see all of the instances, but from a remote client. So that's working quite well. But now let's look at projects, because that's where things can get quite exciting, especially when you're dealing with a larger cluster and you've got multiple users playing with it. Out of the box, you get one project. And that's the one we're using right now. It's called default and has all the features enabled. So now I'm going to create a new project and call it foo. And also, so I can actually show that by default, new projects get all features except for networks, because the network feature doesn't work if you're not using Oven effectively. But you can change that. So long as a project is not used, you can change the list of features. And so if I do edit on there, I can go and add a line here that says features.networks true. Save that. And now we've got all features enabled on the foo project. Now, something that's also interesting is that we can restrict those projects. There are additional configuration keys here that I can set for that. And in this case, what I would like is restricted true. And then let's restrict what networks can be used. So that's the uplink network specifically. So it's saying that this project will only be able to create Oven networks that use that particular uplink. So if you had multiple uplinks, you can then specify them for different projects, for example. And lastly, well, actually no, I'm going to be allowing the use of snapshots, because that's disabled by default if you restrict the project. And also going to be limiting the total number of networks to 10. Let's save that. And oops. Oh, right. Receiving snapshots tells me that the value is block or allow, and in this case, okay, what allow. Cool. So now if I just show the config for that project, we've got all of those things in there. It's good. Now if I look at my client here, I can list the projects and I see the foo project, and I could switch over to that if I wanted to. But there's something slightly more interesting to show first. As you saw, I've been adding that client to the trust store, so we can see it here. It shows as Castiana, and then that fingerprint, we see it's the only client out of all of those. So now you can do config trust edit on that certificate. You can set the certificate, that particular client. First of all, you can give it a name. So let's give it my machine's name. You can mark it as restricted. If you do restricted, then it's going to be limited to accessing some specific projects. So right now, if I just save that as it is, and I go back to my client, it no longer sees any projects whatsoever. I go back, edit that, and in projects, I now go and put foo, and go back to my client. My client now says only foo and cannot access default, cannot access any of the global config, any of that stuff. In fact, if it tries to see the server config, it just gets an empty list. It doesn't get to see any of the config, because there might be, like, this is effectively being treated as a mostly untrusted client, and so will not see many things. It can do things like listing storage pools, but if it wants to try and delete something, it can't. So it's really meant as a consumer of the cluster, as not as an administrator in any ways. Similarly, while it can see the projects and can switch to foo, it is not allowed to modify foo itself. So it can't just go here and say, oh, how about I'm not restricted anymore. This doesn't work. So it's a pretty nice way to sandbox some specific users. You can also limit the amount of CPU and disk and memory and stuff that they get access to. And there's a number of extra restricted keys that can be set to limit a whole bunch of things, like whether they get to access GPUs or USB devices, all of that stuff. Out of the box, just doing restricted equals true actually turns on every single restriction. So that blocks everything, and then you just allow back what you want from that point on. That also means that if we had a new feature in LXD, you don't need to keep blocking things every time a new feature is added. By default, it's going to be blocked. All right, so I've got my remote client. It's talking to that cluster. It's got a project that's dedicated to it, effectively. But the project is empty. There's no instances. The default profile is also going to be empty. So let's populate the default profile a bit. So I'm going to be adding first a root disk. Let's still use local, so it's going to use local storage out of the box, but that can always be overridden on per instance basis. So pull local path / that should be fine. And then it also doesn't have a network right now. It's completely empty. So let's create a default network. And because it's inside of a project, and that's got the network feature enabled, and that's limited to a single uplink, you don't need to specify that you want oven, because that's the only thing that can work. And you don't need to specify what uplink you want, because there's only one. So that should just work. Can be creating a new network. And here we go. New network created. And now let's just attach that to default ETH0 and NIC network default and name ETH0. Okay. So let's try a quick Alpine. The other nice thing with projects is that you don't have any risk of conflict with instance names across multiple projects. So I can reuse the A1 name. Actually, it was C1. Was it A1 or C1? I don't remember. Let me just check. What were they called here? They're called C1. Okay. Let me fix that. I'm just going to delete that instance and recreate it as C1 just to show that this is working. Okay, created and starting. And here we go. You can see that it's running on AMD 6401. And yeah, that's all good. Now, what was the next thing I wanted to show? I think that was mostly it. So let's create a couple more instances in there. Just populating that project that I made. And just to show the restrictions too, if I was to ask for, say, privileged, so a privileged container, I'm told I can't do that. Similarly, nesting is disabled by default, so that will also not work. So that's kind of the benefits of those restricted projects. You can really block all of the potentially dangerous options, and they tend to be blocked by default. Containers and virtual machines are allowed out of the box, but only in privileged containers, and no Unix device or GPU, USB, disk pass-through, that kind of stuff is enabled by default. Now, let's launch a few more containers. So let's do C3, but this one I'm gonna want it on, let's do it on Ceph. So let's just go remote. So I'm just gonna be asking for that specific instance to be placed on Ceph. So I'm just taking a few seconds because it needs to actually load up that image into Ceph. Okay. The next one should be quite a bit faster because there's no need to actually go and copy that data in Ceph. Here we go. So it just needs to map it to allocate some blocks and resize some stuff, but no copy of the image. Okay. And I guess we can do an ARM64 one, just to show it to have access to the different architectures. And that way, then we get on to slightly more storage stuff. So this one, it's a new image because that's the first ARM64 user of that particular image. And if we do, let's do a C6. So it's going to be another ARM one. And there's not going to be any need for downloading or unpacking the image because it's already going to be in Ceph. Come on. All right. So if we look at what we have right now, got all of those running. Okay, last one got an IP. All of them on Intel. We've got some that are on different storage pools, but they're all on the same network. They all can talk to each other. It's all, yeah, it just works. Now, as a reminder, we've got that remote FS pool. So let's create a volume on there. So remote FS call.blah, and let's go. Now, I'm gonna be, because dealing with profile is easier when you've got multiple instances instead of modifying instances individually. I'm just gonna create a profile. Let's call it blah too. And then add to that profile a disk. Call the device blah as well. It's a disk. Its pool is remote FS, and the volume is called blah. And let's make it so that it just shows up as /blah when it's mounted. Okay. Then I can profile add and add two specific instances that new profile. So that's adding it to, let's do C1, let's do, so C1 was one of the ZFS instances. Let's do C4, which is one of the Ceph ones, and let's do C6, which is Ceph ARM64. Okay, and now I get some shell, and if I go C1, so now I've got a new file called blah bar, which contains foo. And just to check that this worked properly, so if I go on C4, which is so it's a completely different storage because this one was ZFS, C4 is Ceph, it's also a completely different system. And just make sure that the shared storage works, it does. And lastly, go and look at that last one, which is on ARM64, and it still works perfectly fine. And gonna show the point a bit further. Let's spin up a, let's do 2004 VM. So let's call that U1. I'm gonna leave it on Ceph, on ZFS because it's just slightly faster. I don't want to have to wait too long. And we'll apply both the default and that new blah profile to it. So that's downloading the VM image this time around. And it's gonna unpack that. And once that's finally done, we should get a virtual machine that also has access to the exact same shared storage as those existing containers. And that's kind of that's the magic of Ceph there. Like, you get to move those instances around whichever way you want. You can have some shared storage that will always work regardless of what machine they might be on. If you lose one of those systems, then you've got a redundant LXD database and control plane, so you can just move the instances to some other systems and start them back up, because there's no actual data that needs to be moved. The only thing that has to be updated on LXD's side is what machine is hosting it. So it's pretty much just a database entry. That makes things really, really flexible. And we're gonna get to see a tiny bit more of that later when going over maintenance and what can be done with like reshuffling instances during system maintenance. So that part is the unpack of the image. Is slightly unfortunate because it takes quite a bit of resources. Those VMs are not super beefy, and the underlying storage for those test VMs is also not super fast. So it's taking slightly longer than normal. As I've mentioned in past videos, if this is only like an initial cost, creating more of the exact same on the same system, or in the case of Ceph on any system in the cluster, will be significantly faster. All right, so this is now starting up, and let's look at its console. Not super interesting usually for virtual machines, but we might see the bootloader or something. Okay, so something is happening. It's probably booting out. Okay, there we go. We just briefly saw the bootloader, and now it's getting into booting, but there's not much output that happens for virtual machines when that happens. Okay. So U1, we see its IP and everything there. Let's see if we can already interact with it and get a shell. Well, minus a typo, but we're still waiting for the agent to start up. Instance is not running. Okay. Yeah, so what happens with most of our images is that they do an initial boot to go through putting files in place for Clarinet, then they reboot to get Clarinet fully applied. So I just caught the instance as it was kind of in between that initial boot and its second boot, where it will actually boot cleanly. So giving it a few seconds to get past that. It's probably not quite started yet, but should be about to. So we see the VM is actually back online. The agent is just not responding yet because it's probably still booting the kernel. And here we go. Okay. So I should say that it, yeah, 0 minute, it just came online now. And the question is whether we've got /blah, and we totally do. So if we look at the DF output, you can see that we've got up to 500 gigs of distributed storage there, and blah bar contains foo. So that's really the magic of CephFS. It works. I mean, if we look at the instances right now, U1 is running on server 05, and the other ones accessing the same file system are on 01, on 04, and on ARM64 too, and it just all works. So this is really quite neat. Now, the other thing I can touch on quickly is because we're using OVN, we get to play with ACLs a bit. So there's a separate command called LXD network ACL. We can create a new one, say block SMTP, and then edit the ACL. And there's an example at the top. So in this case, let's say it's an egress rule, and action is block the rule is enabled, protocol is TCP, destination port is 25, and that's probably good enough. Action must be, oops, right, it's reject for the action. Okay, so now I've got that new ACL. If I look at my instances, and let's pick the virtual machine again, because it's got Ubuntu with a few more tools. So if I go there and I use netcat and I do smtp.gmail.com on port 25, I can connect. So there's currently no blockage happening there. Now I can go and do config device override on U1, network card, and then security.acls, I believe is the name of the key, and apply block SMTP. Now if I go back here, this is now rejected. Just to make sure that the rest still works, can we ping something? No. Oh, right. Never mind. This is my fault. The ACL, so if you don't have any ACL applied, it will, so without any ACL, it's gonna allow everything. As soon as you put ACLs in place, it will block everything by default. So in this case, what I can just do is create another ACL. Let's call it default. And let's just do egress action allow state enabled, which would allow everything. Now, if I go and just do device set and modify that to be to have default applied to, that should work better. Yep, so I can ping again, and Gmail is still blocked. There we go. Now, I apply that to a specific instance. So if I go now in another instance, no bash in Alpine, keep forgetting, this still works. So either I can go and like apply it to the default profile, or I can also set it on the network itself. So I can do security.acls default block SMTP. And just make sure we still have connectivity. Yep. And that no longer works. So that's another nice thing with when you play with OVN, is that you've got the full support for LXD network ACLs that can be quite flexible about like different range and different instances or group of instances that can connect to something. So you can make some very, very flexible ACLs, much more than you can without OVN. So that's just for the network ACL part, which is always a nice feature. And again, just as a reminder, I'm doing all of this inside of a restricted project as effectively an unprivileged user talking to that cluster. I'm not an administrator or anything, and none of the actions I did here would impact anything other than my own project. So it's really giving you like your own sandbox, and you can do whatever you want in there. It's super flexible. So going back to the administrator account, effectively where I can see everything, not just the full project. Let's create another project quickly here. Create bar project switch. Actually, there was something else I wanted to show. Sorry. So in the default project that I'm in, we've got instances that are on a default network. Now, they're on 10.46.99 something. Let me get the Ubuntu one actually. Yeah. Those are on 10.96.192 something. And they're not going to be able to ping each other because they're all NATed and there's no root, there's nothing there. Now that can be changed. LXD has support for network peering, so for connecting two networks, even across projects, even when, as is the case here, my user is restricted and is unable to see that default project. So what I can do is do LXD network and there's a new command called peer. So you do peer create, and just the help there. selects the network that it applies to. So it's default in this case. The peer name, let's call it default project. Then name of the remote project, so it's default, and the network is also called default, so it's a bit repetitive. If I do not, it tells me that it's pending, and we should be able to see that in the list. Yeah, list and then network name. There you go. So it shows us pending, and what I need to do now is either have the administrator do it or have someone who's got operator privilege on the other project do the reverse. So you'd go here and do network peer create default foo project, and it's foo/default, and it shows peer created. If I go back here, it's created, so it means it's live. Now if I go here, now I can ping. So that lets you, like, even though the projects are completely isolated out of the box, if users of different projects want to be able to reach each other, they can totally do that, like, mutual peering thing to then connect them. Obviously, the networks must be non-overlapping, so they need to be careful about that. If they've chosen their own network ranges, then they need to make sure that there's not going to be any overlap. But it's a really neat feature that can be used in those kind of environments. Anyway, back to creating another project. Did I actually do it? I did, but I think I did it without the network feature, so let's just recreate it again. Project create and features.networks equals true. Okay, so that creates a new project with all the features enabled. And with that one, let me switch over to that. It's going to be easier. Just need to also create a network. So let's just create a network called default. And oops, I forgot this one is not restricted, so it doesn't know what I mean. Network default. Okay, oven. Fine. I think we've got enough networks around now that we need to specify which the uplink is, because this is not a project that's restricted to a single uplink. So it's asking the question. Fine, so that should work just fine. Yep. All right, so I've got a default network. Now let's configure the default profile. So in this case, I'm going to do root disk. Let's use Ceph by default for that one. And it's for the root disk. Okay. And do the network next. Okay. And actually, let's do some more Alpine. That was fun, so let's keep doing that. I keep also reusing the same names to just show that you can have as many projects as you want with the exact same instance names, and it just all works fine. So in this case, this one is running everything on Ceph, so those instances are super lightweight and can be moved around on any system as needed. Which then gets us to, oh, actually there was something else I wanted to do in this profile. I'll do it next. I wanted to show how you can do snapshot handling as well in LXD. So just do, so in this case, I'm going to modify the default profile and set two config keys. So one is a snapshot schedule. So I want it to happen every time an instance starts as well as daily. And I want it to expire after 7 days. Schedule must be found. This is confusing. Okay. Pretty sure we support the comma separated section. Syntax. I'm not sure what's going on right now. Maybe it's the daily that's not being parsed properly. In any case, startup will be enough for the demo. So if I say I restart one of them, this is going to cause a snapshot this time. So the startup's going to take slightly longer because the snapshot is going to be performed as part of that. Shouldn't take too much longer. Yep, snapshot got created now. And same thing, if I spawn another instance, then this one's going to also create snapshot startup. And let's probably make taking the snapshot right now, which is why starting is taking slightly longer than usual. Okay, and here we go. So that's pretty neat. That also means the snapshots happen automatically in the background. Snapshots and backups are restricted features in projects, so you need to enable them. But as I did for that foo project earlier, if we look at its config, that particular project has snapshots set to allowed. Okay, so that's a reasonably complex cluster with a few projects and restricted access and instances running and OVN and Ceph and all of that fun stuff. Now, what happens if you need to do some maintenance? So looking at my systems, let's say I need this guy 05 to be restarted. So it's currently fully operational and I need to do maintenance on it. So what you can do is cluster evacuate and then name of the system. You need to confirm, and then LXD will look at all the instances on it, and unless it's configured otherwise, it will look at migrating instances to other systems. So it will briefly stop them, move them somewhere else, start them back up. We don't yet have support for live migration, especially for containers in this particular feature, but that's coming for virtual machines very shortly. And yeah, it means that for every single instance, it will either stop it, move it somewhere else, start it back up, or if the instance is using resources that are local to the machine that it's running on, the instance will just be stopped and its state remembered. So that's completed. Now if we go look at that machine, so it's 05, just this guy, we can see it's running absolutely nothing. All the instances are all gone. So now I could easily go and reboot the system. And if we look at the cluster state, it currently shows unavailable due to maintenance as the status for that particular system. And if given enough time, it would eventually show that it's actually completely down, as in not responsive. But I suspect the system will reboot fast enough that this won't happen. The other thing we can see is because it got evacuated and got taken offline, the database roles have reshuffled. So it used to be database standby, now 06, which was nothing before, is now database standby. So those roles do move around. Let's just see if the system is back. Not quite yet. It can't be far, but it's not. Yeah, it's still rebooting. Okay. I'll give it a few more seconds. Because the other part of it is like, well, once it's done, when the maintenance is over, you need to actually move stuff back onto it. So, okay, it's pinging again. SSH is working again. In a few seconds, gonna have LXD running on it again. Yeah, LXD is currently starting up. And waiting for everything to be ready. Okay, it's importing the local pool. We can see here, and like in this case, you can see the Z pool being imported. Anyway, it's back. It's back, but with no instances, and we can still see it as evacuated right now in the list. And what you do is you do restore, and then the name of the system, confirm, and that will do the reverse. So it's gonna look at the instances that were moved earlier, will stop them, move them back, start them back up. And for any instance that was on that system that could not be moved elsewhere, it will just start it back up at that point. So that also means that you can safely reboot the system with like no fear of random instances coming back online on that system until you do the full restore operation. And that's it. If we go look at what's on that thing, it's running a container again. So that's the cluster evacuation. That's how you do maintenance on LXD clusters. Just checking that everyone is happy here. So that was, let's look at foo, they're all running. Default, they're all running. So yeah, well, we're all good. The system wasn't running very much, so it didn't take too long to evacuate. My production cluster is running something around 100 plus containers on just 3 systems. That takes a bit longer. We on purpose don't do it all in parallel. It's really done one instance at a time so that there's not extra strain really put on the cluster. And LXD also picks whichever system it finds with the fewest number of instances to then evacuate instances onto those. That just avoids like all of them being shoved onto the same system, so it kind of tries to spread the load temporarily as the system is taken out of it. And yeah, that's effectively it for this deeper dive into clustering and how to run a more complex LXD cluster environment. And I hope that was useful. Hope you found you learned about some new LXD features or new ways of using LXD. There's a lot more I didn't get to include in there. Like we've got additional oven features for things like floating IPs, so IP forwards. We've got support for dynamic routing with BGP. We've got support for all whack ton of hardware pass-through, whether it's like Unix devices or USB devices or GPUs or all of that kind of stuff. I didn't show how to also run DNS zones for each of those projects that can then get you forward and reverse DNS records on all of the instances. That's something else that is useful on pretty large clusters. Yeah, there's a lot more, and we'll put link to the relevant documentations in the description below. It's also just for the Ceph and Oven part, a reminder that there are YouTube videos that we made for those, and I'll put in the description below a link to all the commands I use to set up this particular 8 machines cluster. So that's specifically the commands I use to set up Ceph and Oven ahead of recording this video. But I'm also gonna put the shell history just in case that's useful for people. And yeah, I hope you enjoyed that. I hope that you find something useful to you and that you might consider using LXD cluster for something. It's really super flexible, especially with an environment like this where like it's completely HA. You can do maintenance of any systems in there. Just do it once at a time if you're doing the control plane machines. You don't want to take 2 of those out of this at the same time. But yeah, that's what I've been doing in production, both for a cluster at a data center and a cluster run at home, where I do weekly maintenance for like kernel updates and some other stuff. And when running kind of HA services, like redundant services, for all of the stuff that's running on there, there's barely any visible downtime. Like it might be that a few clients just lose a connection as they get as the load balancer moves them to another server as one goes down. But it's effectively, yeah, completely invisible to the user when that kind of maintenance happens. It also makes you feel good about your environment because like there's nothing more dreadful really than servers that have been running for months or years that you really fear about rebooting, and having such a redundant system where no machine is really special, no machine really holds any particular data, any of those machines can burn up in flames and you won't really lose anything. That's really, really valuable, and just makes your life so much nicer. Anyway, if you've got any questions on this quite long video, leave it in the description below or on the community forum. And yeah, hope this deeper dive into clustering was quite useful to you. Thanks for watching. Bye.